Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My name is Amir Muhammad Rosli. My student ID is 2024800256 and today I will present to you our CSC508 Assignment 2 about Pharmacy Store Management System.
First class is not the Java. This is the most basic building block used by the linked list. So it has two fields, which is data of type object, which store the actual value, and next of type node, which is a reference pointing to the next node in the list. We have three constructors: a default constructor that sets both to null, a constructor that takes only data, and a constructor that takes both data and next node reference. So this node class is used internally by linked list, and since my stack and my queue inherit from my linked list, they also use this node class. The two exception classes, which was the empty list exception, extend runtime exception. It is thrown whenever we try to remove our access element from an empty linked list, stack or queue. It has a two constructor, one with a default message and one that accept a custom message. So another one was a release exception, which also extend runtime exception. It is thrown when the array list is full, empty, or even when an index is out of bounds. This custom exception makes the error handling cleaner and easier to understand. Now let me explain item.java. This is our concrete class. It represents one medicine in the pharmacy. It also has 6 private fields, which was medicine ID, medicine name, category, price, quantity, and supplier. We have a default constructor that initializes all fields to empty or zero values, and a parameterized constructor that takes all 6 values as argument and assigns them using this keyword. For every field, we have a getter and setter method. So as we can see, for example, get price returns the price and set price updates it. We also have two alias getter, get item name and get item ID, which return the same values as the medicine as get medicine name and get medicine ID. These alias are used internally in the application. Finally, we have the toString method, which formats all the medicine details nicely for display in the J option field. Now the most important class, my linked list.java. This is the base class that both my stack and my queue will inherit from. It has 3 protected node reference, head, tail, and current, and a protected integer length. They are declared as protected, so the subclasses, my stack and my queue, can access them directly. So the constructor initializes everything to null and length to 0. Is empty simply checks if head is null, get num returns the length, and insert at back creates a new node and adds it to the end. If the list is empty, head and tail both point to the new node. Otherwise, we set tail.next to the new node and update fail. So as we can see here, insert at front adds a new node at the beginning. If empty, head and tail both point to the new node. Otherwise, we can create a new node that points to the current head, then update head. Remove from front, it throws empty list exception if empty. Otherwise, it save the data, move head forward, and decrement length. And get first and get next are traversal helpers, and get first sets a current to head and return its data. So get next move current forward, and also it will return the next data. These are used in the display method. Pick front returns the front data returns the front data without removing it. So here is my stack.java, which extend my linked list. This means it inherit all the method we just saw: insert at front, insert at back, remove first, get next, and pick front. My stack adds 3 methods on top of that. Push calls insert at front, so every new item goes to the top of stack, which this gives us LIFO behavior, last in first out. Pop checks if empty first, then call remove first, which remove from the top. Pick calls pick front, it lets us see the top item without removing it, so the stack top is always the head of the linked list itself. .java also extend my linked list, same inheritance. Enqueue calls insert at back, which new items go to the back of the queue. So this gives us FIFO behavior, first in first out. The queue check if empty, then calls remove first, which will remove from the front, and pick calls pick front, which will shows the front item without removing. So the queue front is the head of the linked list and the rear is the tail. My array list use a fixed size object array to store data. It has 2 constructors. The default one sets everything to null, and the parameterized one takes an integer k and creates an array of size k. In our app, we use size 50. So insert n checks if the array is full first. If not, it adds the item at index length and increments length. If full, it will throw array list exception. And get data returns the element at given index after checking for emptying and bounce. And the last one, remove at, which will remove the element at index I by shifting all element after it one position to the left, then decrementing length. Inventory app.java is the main application class. At top, we declare 3 static objects when array list of size 50, the queue and a stack. These are static, so all method can access them directly. In the main method, we first call preload data, which adds 8 medicines into the array list automatically when the program starts. Then we enter a while loop that keeps showing the menu until the user enter 0. The menu displayed using JOptionPane.show input dialog. The user input is parsed as an integer and passed into a switch statement that calls the appropriate method. Each method is separate and clearly named, such as add item, delete item, search item, display array list, calc sum average, calc min and max, and enqueue item, display queue, push item, display stack, copy to queue, and move queue to stack. If every method that takes numeric input wraps in a try catch for number format exception to prevent runtime error. So every method also checks is empty before trying to access data to avoid exception. The program and demonstrate each feature. So when I run the program, 8 medicines are automatically loaded. So let's choose option 1, the add ID vitamin C. And medicine add successfully. So let's try search the medicine itself. 5 see, and it will show you the medicine ID. So let's try delete. So vitamin C deleted successfully. So let's try display all array list, and here all our drugs on our stock. So let's try sum and average of prices. So it will tells you which we have total 8 medicines. Sum will be 56.10 ringgit and average will be 7 ringgit and 1 cent. So let's try min and max maximum prices. The cheapest one will be paracetamol 500 and most expensive one. So let's check the NQ to Q medicine ID. So vitamin C and Q size 1. So let's display Q. This is what we wrote before. So let's add another item to check the people it works or not. So let's check, and there we go. So let's try to push stack. So with vitamin E push stack size 1. So let's try another one. Display stack, and there we go. So let's try copy array list to Q, and all the item on array list is insert to Q. So let's see display Q, and there we go. So let's move Q to stack, and it done. Move it medicine. Q is now empty, which move. So let's see the Q. It will empty, and let's check the stack, and there you have it. So that concludes my presentation. This application successfully demonstrates all required features: store, delete, find and display item, calculate sum, average, min and max, and copy and move data between data structure. My stack and my queue both inherit from my linked list as required. So that's all from me. Thank you for watching.